Let me ask you something. Would you trust an AI that nails 95% of natural language tasks, but chokes on logic problems that a $5 calculator handles no problem? Because that's exactly what LLMs do today. That a $5 calculator handles no problem? Because that's exactly what LLMs do today. And the solution to this problem has a name: Neuro-Symbolic AI. What's up? I'm Pedro. Today we're diving into one of the most important and most underrated topics in modern AI: combining neural networks with symbolic reasoning. If you've been frustrated by hallucinations, logic errors, or answers that sound right but are completely wrong, this one's for you. Alright, let's be honest about the limitations here. LLMs are statistical language models. They predict the next token based on patterns. That's brilliant for generating text, translating, summarizing, anything language related. But logical reasoning, multi-step planning, factual consistency, that's where things fall apart. Here's the fundamental issue. LLMs don't actually reason. They do sophisticated statistical pattern matching. When you ask if A implies B and B implies C, then A implies. The LLM isn't doing logical deduction. It's looking for the most probable pattern in its training data. And that works until it doesn't, especially with edge cases, specialized domains, and long chains of reasoning. That's where you get those confident-sounding answers that are just flat out wrong. So here's the idea behind Neuro-Symbolic AI, and honestly, it's pretty simple at its core. Use neural networks for what they're great at: understanding language, recognizing patterns, handling ambiguity. And use symbolic systems for what they're great at: formal logic, planning, consistency, verification. Use neural networks for what they're great at: understanding language, recognizing patterns, handling ambiguity. And use symbolic systems for what they're great at: formal logic, planning, consistency, verification. There are three main architectures that are actually working in production right now. First one, Neuro-Symbolic integration. The LLM translates natural language into symbolic representations, like first-order logic, knowledge graphs, or executable code. Then a symbolic engine processes that representation with formal rigor. Second, symbolic grounding. You anchor the LLM to structured knowledge bases. Instead of relying on the model's statistical memory, you make it consult a verified knowledge graph before answering. Instead of relying on the model's statistical memory, you make it consult a verified knowledge graph before answering. Third, and this is my favorite, Neuro-Symbolic programs. The LLM generates programs, actual executable code, that solve the problem. The reasoning doesn't happen inside the model. It happens when the program runs. That third approach, by the way, it's the foundation of what we call code as reasoning, and it's probably the most powerful one for us as developers. Let's see this in action. I built a simple pipeline that combines Claude with a logic verification system. The user describes the rule in plain English. The LLM converts it to a formal logic representation in Python, and a validation engine runs the verification. Input from user. Every order over $1,000 from a premium customer with more than 2 years gets free shipping, unless the region is north. The LLM converts that into, and the symbolic engine runs this against every test case, every edge case, every possible contradiction, automatically. The result? The rule is validated formally, not statistically. Zero hallucination, zero ambiguity. You can actually trust it. Neuro-Symbolic AI isn't some far-off future thing. It's an approach you can use today in your projects. Anytime you need reliable reasoning, combine the flexibility of an LLM with the rigor of symbolic systems. In the next video, I'm going to show you how to build a context engineering system. If you enjoyed this deep dive, smash that like button and subscribe. See you in the next one.